today's class is using CoppeliaSim to do pick and place. Okay, and I decided to go with a simple 2D example. So here you can see from the figure, we need to move the block, the blue block from this position from where it is to this black dot. And we typically don't do it, go from left to right in the straight line, but we actually want it to go from here to some point here and then get it down. And that's just because, this place might have more blocks and you don't want to collide that block with other blocks. So I'll just set it up for one block, but then I'll show you how you can generalize it to multiple blocks. So the way this goes is here's a video of the final result for today. And then place it and then release the block and move back to that point on top. Okay, so what we'll do in this class is we'll set up the manipulator in IK mode. Okay, then we'll actually put a force and a proximity sensor to the end effector. The end effector is actually the link 3. There's an end effector here. So we'll put a force and proximity sensor, which will in turn help us to detect this block and also connect it to the link through the force sensor. So the force sensor part is new. It's not been done before. And then it's all about setting reference positions going from point A to point B. And then finally, I'll show you how you can grasp and release object by using the connector. Okay, and these are the two new commands. Well, this one is not new, but the object parent is a new command we learned today. Okay, so let's get started. Okay, so this is an example from, well, this file is something which you've seen before. It was part of your homework, right? On inverse kinematics. I'm going to modify this file. Okay, so first thing I do is I set this manipulator in IK mode. For that, I go to joint, IK mode, then joint 2, IK mode, joint 3, IK mode. And I also need to set the links to be not dynamic or static. So here is making those links static. And finally, link 3. Okay, so now I'm ready to start putting some dummies onto the end effector and give a reference position so I can do IK. So let's add a dummy. Okay, and I'll call this end effector. And I'll put this as a child of link 3. Okay, and one of the advantage of doing that is that if I want to then place it at the end effector, I just have to open the translation button up. And then I just say position with respect to the parent frame. The parent here is link 3 is 0, 0, 0. Okay. And so I don't know if you can see it, but it's right here, right over. Let me just move it so that you can see where it is, or rather change the size of the dot. Let's make it 0.05 and adjust dummy color. Let's change that to, so I think this is good enough, but yeah, so you can't see it because it's actually below the end effector. Okay, so it's here in the middle of the end effector, and I know that the length of the end effector is 0.5, and so I'm going to move this to the left by 0.5. I believe I change the X. There we are. It's at 0.25 or the end effector. Might be easier if I switch this view. We turn this. Okay, and then switch back. So I just double click. Okay, so you can see the end effector, and it's the other view, the top view is here. Okay, so now I will create a reference position, which I can then move around so that the end effector will follow the reference. So add dummy reference, And the reference, let's change the color and the size. Let's make it 0.05. Let's make that maybe green. Okay, that looks good. And it's right here. So one trick, and this is something which I've realized makes it very easy, is to actually make it a child of the end effector. Once you do that, you click on translate and then just make it 0, 0, 0 with respect to the parent frame. So it's actually sitting right at the end effector. And once you do that, now you remove it out of the chain. And so now it's free. And now you can move it the way you want. But that way it ensures that the reference position is in the same plane as the end effector, especially the z coordinate, which is up. Okay, so now let me move it here. Okay, now I can go ahead and do the IK, but before that, I still want to add two more sensors. I want to add a force sensor and I want to add the proximity sensor at the tip. So I'll do that next. Add proximity sensor, say ray type. We call that proximity. And I don't know if you can see, but it's right here. This is actually 0, 0 for the plane. Okay, so I'm going to take this and make it a child of length 3 and press translate. This way I can easily position it at the tip, right? So we've seen that it should be 0.25, 0, and 0, just like what I had for the end effector. So now you can see it's right there. Okay. However, you can see that from this figure, you can see that the proximity sensor is pointing upwards, and we really want to use the proximity sensor to see the objects here in if you can see here, it's along the x direction. So we want to rotate the proximity sensor by 90 degrees about the x or y axis. It's probably y axis. So rotation 90 degrees. And it looks like it is now. You can see this slight red line that shows that it's pointing towards the positive x direction. That's what I want it to be. Okay, so that is the proximity sensor. I also need to add a force sensor, which is a new element uh, in this part of the course. I'll call it actually connector. And I'll call it connector because it will actually help me connect the block to the manipulator, and then it helped me to release the block. So I'll call it connector. I'll move it to link 3. Then I'll do the usual thing, translate 0.25, 0, and 0. And so the connector is now here, but let me just switch the views and let me move it out so that you can see how it looks. So translation, one frame. Okay, here it is. So you can see that the connector is pointing upwards, which means, so that, how do I know it's upward? Well, you can see that the black cylinder in the middle is aligned along the z-axis, which means that it will connect anything along the z-axis. But I want it to connect along this axis, the axis of the manipulator. So I need to rotate about 90 degrees about the y-axis, just like before. So rotate 90 degrees, and now it is pointing in the way I want it. Let me show it to you. See here, it's pointing in this direction. Okay, so change the view, and let's move it back to the place I want it. So again, the trick is open translate, change the position to 0.25 in the parent frame and 0. So now it is right at the place I want it. Okay, so I've succeeded in getting all the sensors I wanted on for the manipulator. Now let us proceed to figure out the IK, which is something you've done in the past. So connect the end effector to the reference position by right-clicking, first selecting them, then right-clicking. There is, edit, add, link selected dummies. and I say IK tip target. And when you do that, you should see that there is this line which shows that they are connected to each other. Okay, I'm going to close this part. I don't need it. So this is how we close it. Okay, so I've connected the two. The last step to be done is to link the two to a new IK group. So new IK group, read IK elements. Here I want it to be the end effector. So add, and then since this manipulator is, so by the way, here end effector connects to the target, which is the reference position, which is this one. I wanted to follow the reference in the XY plane, so I'm not really looking for Z. So I'm going to deselect Z, close that, close this. And now actually if I run this, it's going to be create, it's not going to move, right? I expect it to move there. And that's because this manipulator is actually in a singular position. So if you want it to move, you need to change the angles of the manipulator from being perfectly straight to something else. So for example, if I change this to say minus 70, okay, and let's hope it'll work now. Let's see if it works. There it is. So it moved, right? But let's make it slightly easier for the manipulator to do that. I'm going to change the angles a little bit more. So it looks about right. Okay, so let's change the join 2 to, let's try 50. Okay, let's go more, 80. Okay, and then join 3. Let's try, let's see, 40. Increase it a little bit more, 60. And this is really arbitrary. I'm just doing that. Okay, 7. That looks good. Okay, so now when when I go and run this, you see that what you see is that the end effector is not connecting the reference position in a vertically downward position, right? So you need to change that angle. The way you do it is, and this is something we've not done before, so I'm going to stop this. First of all, what I'll do is I'll go to kinematics, edit IK elements, and then here, I remember I did X, Y. I'm also going to force it to satisfy the gamma one, the gamma orientation. The gamma orientation is the theta orientation in the plane, okay? So let's see what happens if I do that. Okay, now you can see that the end effector is connecting to the green dot, the reference position, at an angle which is along the x-axis, right? However, I want it to connect such that it is along the y-axis. So what I do is I simply go to reference and I rotate the reference by 90 degrees along gamma. So, okay, and let's see what that does. So now you can see it's connecting the green dot in the vertically down direction, which is exactly what I want for it to pick the box and paste the box. Okay, so that is the IK. Okay, next step would be before I introduce the block and get it to move, I want to decide a goal position where I want the block to move. So let's create a new dummy and let's call that dummy goal. Okay, and let's put like a black color so it's obvious. Now we can move it the way we want. So let's say that the goal should be here. Okay, again, randomly placed. Okay, now we also, as I said, instead of moving the block, which I'll put over here, directly from left to the right, I want the manipulator to pick it and take it here and then go down. So this is actually this point which I'm going to create. In robotics, it's called a via point. Via point is because you want to manipulate to go from A to B via C, and so that it doesn't collide with anything else. So let's create a new dummy, add dummy, and I'll just call it via. Okay. And then let's give it some color, maybe pink. Okay. And let's move it over here, right on top. Okay. Okay, the final step is to add the last element, which will be a box. So add a cuboid. And since I've done this before, I know that the right size is about 2. Okay. And let's call this box. And let's change the color to blue. Okay, let's move it slightly to the left. Okay, so far so good. We've created the box, we have created the points. Now what remains to be done is to get this manipulator to go from here, this point, to this point, the black dot, via the pink point. Okay, so let's just plan the movement of the end effector from the loop, the box, to the pink dot and to the black dot before we actually talk about how to grasp and things like that. So this will involve some coding. Okay, so I actually I made most of this thing so that I'm not wasting time writing them from scratch. I got all the handles for the reference position, the end effector, the connector, the proximity, goal, box, and the via point. Okay, so that will make life easy. Now, since I wanted to go from the location of the box to the goal via the via point, I get the position of these points using sim.get object position. I called it pick because that's the picking point. Then I have the goal point, which is sim.get checked position goal -1. Okay, so it says case sensitive, so you can't put a capital G, so it should be small g. And then finally, let me get the via point for the position of the via point. Okay, so I got all those positions. Okay, now I just have to set it up in the code to actually go in and pick. So it's always good to have the simulation time. So I'm just going to use that to drive the simulation. Sim.get simulation time. Okay. Okay, so now let's do sim.set object position. So this is not a new command. You've done this to draw the asteroid for the homework. And what I need to do is I need to take the ref position and then make it go to the position I want it to go. So for example, position pick, right, which is the box position. And this has to be done in the world frame that is indicated by -1. Okay, you can look at the manual for how this command works, set object position. Okay, and then let me just introduce a delay. So let me do this at t greater than equal to 3. So that is, it will wait for 3 seconds before it actually does it. And I'm only doing that because otherwise, it will be so quick and you will not be able to see the actual effect. Let's close this and run. So you see that it actually went there, but it sort of kicked the box out of you. So we can play it again. So it actually punched the box. And what went wrong there was the fact that when I get these positions, right, when I got the position of the box right here, it actually gave me the position of the midpoint of the box. And so when it tries to go there, it invariably kicks the box away. Okay. So the question, what is line 24 doing? Okay, line 24 moves the reference to the position pick. Okay, so what's doing is it's taking this reference, putting it right here, and when it does that, since the end effector is linked to this reference point, it moves the end effector right over here. Okay, so as I said, it's trying to move it at the midpoint of the box, which is a problem because then it's going to kick the box away. Now I know that the box is 0.2 by 0.2 by 0.2, so I really want it to be here, right? Not at the middle. So this distance is 0.2. So what I need to do is, if you look at this, the Y position, I need to go not exactly at the center, but I need to subtract out 0.2, and that's where I want to put the end effector. So what I'm going to do is, I'm going to pick up the position of the y coordinate, which is the second, and then subtract 0.1, okay, because the length of the box is 0.2, so that's halfway. And now let's try this and see what happens. Okay, so it did not kick the block out. It looks perfectly fine. Okay, let's stop this. Okay, now what I'll do next is I'll basically use the time to set the manipulator to go from this point to the VIA point, then to the black dot and back to the VIA point. Okay, and I'll do that because that's the path I want the manipulator to take before I actually program the grasping and release. Okay, so let's do that. Okay, so I wait for 3 seconds and then it does the pick. Let me keep going here. Okay, now these times are arbitrary. I'm just assuming I'm going to do this for 3 seconds each. So and t less than 6. So it waits for 3 seconds at that position, picking position. Then for the next 3 seconds, I want the manipulator to go to the VIA point, right? Okay. In the next 3 seconds, so 9 to 12, I want the manipulator to go to, so it's gone from here to here. Now I want it to go to the goal position. So I'll write this as goal. Okay. Okay. Next, I want it to go from goal to the VIA point, and that's where I want it to stop. So from 12 to 15, I want it to go to the VIA point. Okay, so I think I'm all set. Let's see what happens. Perfect. So it actually did what I wanted it to do. Now, the last piece which is left is to actually pick the blue box, right? Then go to the VIA point, go to the black dot, release the box, and then come back to the pink dot. Okay, so that's the last part which will help me get done with this. Okay, so this is relatively new, what I'm going to do. Okay, so what I'll do is somewhere once it reaches the pick position, it needs to, here somewhere, I need to make the robot, just put this in context here, and effector grasp the object, right? This is where I want the code to sit, which will grasp. Second thing I said was when it reaches the black dot, I want the manipulator to release the box. So that should be goes to via point, then it goes to goal. So it should be after it reaches the goal, I need the end effector release the object. Okay, so I need to write something there, some code which will do that. So what I thought is, instead of doing this over here and making that code clunky, I'm just going to make a function called grasp object, and I code that. So it will call this function here, and that function will take care of grasping the object. So what I need to do now is write this function. So this is probably the first time I'm doing a new bringing a function call, but you've actually looked at functions, right? This is actually a function call. It has to be exactly like this. It should be called function, name of the function, and should end with end. So I'm going to now create that function. So let me call it function grasp object and then end. Okay, now I need to write some logic which will actually grasp the object. Okay, so this is something which uh, is new and sort of the way CoppeliaSim works. Uh, what I need, what needs to be done here is, when the manipulator is over here, it needs to figure out what shapes it's able to pick up. Right now, in this case, there is the manipulator. There is the 3 links, 4 links to the manipulator. Then there's the blue box, and all those shapes are valid shapes. All these things are valid shapes, right? But it should know that this object is the only one that is to be picked. Okay, so there's a way in which it cycles through a list of all shapes, and that code is something which they have provided, and I'm going to just copy paste that. So this is something which the way CoppeliaSim operates. Okay, and so you sort of have to remember it, or how it's done. So while true do, and I would just copy this every time you try to do something like this: objects index sim dot object shape type. Okay, let me write this whole thing down, and then let me explain to you. If shape equal to -1, -1 is usually the ground. Then break end. Okay, and then the piece, and then of course I need to do index equals index plus 1. Okay, so this is the bare minimum code. So what's happening here is, once it goes to grasp object, which is called right here, it basically, I'm going through a loop, okay, with the loop is indexed by index, and I go with this new function called get objects. And what this get objects does is, basically it gives you the, if you send it index 0, it will basically tell you, it'll basically return the handle called shape. This shape is actually called, is a handle.
Professor, I think you forgot the equal sign at the bottom.
Did I? Yes. Yeah. Thanks. So the shape parameters in this code are basically, if you see here, these are the shapes, right? So it's basically queuing for all the shapes. So if it sees a plane, then it will return back the handle of that shape. So for example, in this case, I have link 1, link 2, link 3. These are all shapes. So the moment I put index sim object shape, it will return the handle for link 1, sorry, base, link 1, link 2, link 3, and then box. Okay. Now, from all these shapes, it will keep cycling it till it reaches -1. The last value in this table, something which we don't see, is actually the ground, okay, which is -1. So what this tells is, if you reach -1, then break, and then you just increment the index by 1. Okay, so this is piece only gets me, cycles through all the shapes which are available. What I need to do specifically now is, I need to pick up the blue shape or the box from this. And so what I ask myself is, what is the feature of this blue box which is different from this link 1, link 2, link 3? Now, one thing we know is that these links are set in IK mode. Okay, so they are static, right? While the block is not static, it's actually in dynamic mode. So I'm going to sort of exploit that information to Well, actually, is that true? Yeah, it's true. So I'm going to exploit that information to actually get the uh, get the box identified, which can then be used to link. The second thing which I can do is when this link goes close to the blue box, it basically sees that it is in the vicinity because I have a proximity sensor. So I can use that information too. There's other piece of information like this piece is respondable, then you can also use that information. So what I'm going to do is uh, let me use, okay, here are the various options. I'll give you multiple options. We don't have to use all of them. So this parameter, this code basically does is it basically takes that shape which it identified, the handle, and sees if that handle is respondable. Okay, if it's respondable, then it returns if respondable, then it returns parameter 1 equal to 1. Okay. Okay. Again, how do I know this? You need to actually go to object in 32 parameters, check out what are the options, and I think this one corresponds to 3001 or something like that. Let me just pull it up so that you can see it. Okay, so set object int 32 parameter, list of all identifiers, and let's see this one. And I basically got this from one of the examples. They have an example where they do a gripper, and they actually are given this code. And that's how I came to know about it, and that's how I am using it. So let's search for this. So you can see sim object respondable. That's 3004, not 3001. And basically, what it does, it if it's respondable, it returns 0 or not equal to 0. Okay, and then the other one which you might want to use is actually shape int param static. Okay, so let's see, this is, yeah, that is 3003. So this one is telling you if that object is static or not. Now we know that the blue item, the blue box, is actually dynamic while all the items are static. So you could use this one too. So let me just put that down also here. Result 2, parameter 2, and then it's called shape int param static. Okay, so what it will do is it will say if shape is static, okay, then it will return parameter 2 equal to 1. Okay, which is it's true. Here it is. Here the box is dynamic, right? It's not static, so it will return parameter equal to 0. Okay, and finally, I also have a sensor there, and I can use the information from sensor. So let me just pull that up. Okay, the final thing I could potentially use here to detect the shape is result 3 distance check proximity sensor. So proximity is the handle, and then shape is the object. So it's sort of going to use the proximity sensor to look at the shape, which I actually got over here, which is basically all these indices. So that will basically return result 3 will be equal to 1 if the shape is detected. Okay, so I have these options to trigger to actually identify the shape. So what I'll do is let's just use the proximity sensor. That's just easiest. So result 3 equal to 1. Okay, I'm saying that I'm using the fact that the proximity sensor detected the object, then what I need to do is I say I need to attach it. So I'll say attached shape equals shape. That is just saying that this shape is going to be the shape which I selected to attach, and I'm going to attach it next. So I say set object parent attached shape. Okay, that's the shape it's going to attach. It's going to be attached to the connector, and then it's going to be true. Okay, so this is a new command. So I'm doing some error here. Sim dot set object parent. Huh. It should have been in red if it was. Let me just search for it. Oh, it should be sim. My bad. Okay, so now let's search for this. What is this thing actually doing? So go to the manual, to the API, search for set object parent. Okay, set object parent is right here, the Lua synopsis. It says that you give the object handle. So in this case, the object handle is the shape. You give the parent object. Right? What's the parent? The parent object is basically the end of the effector, and then keep in place. So keep in place indicates absolute position orientation should stay the same. So clearly you want it to be true because you want the orientation to be the same. So you just say true. So let's see if that mirrors what I wrote down here. Let's copy this. Okay, so object handle, that's the attached shape. Clearly, this is the object I want to attach. I want to attach it to the connector, which makes sense, and then it's true. Okay, so this looks good. And then here, since I already identified the object using result 3, the proximity sensor, and I already attached it, I'm free to break from this loop. Okay, did I end the loop? This if end. Looks like I did not end. This end is for the function, so I'm missing an end. Maybe this makes it more clear. Okay, so I think this will work. Let's see. Okay, there is a problem. One of the is argument type is not correct. Set object parent. So line 66. Right here. Yeah, this is the problem. It should be shape. It's very sensitive to attached shape. Should be the same. Looks good. Let's run this now. One of the functions argument type is not correct. You have a D. Okay, let me, I did an error. I'm sorry about this. Let me just copy paste. That's the easiest, cleanest way of doing this. Take this, copy it, and then paste it here. Yeah, maybe shaped is, let me just call it shape. Okay. Let's go. Okay, lifted, put down, lifted. Okay, so it's lifting and going to the place I wanted, but at the black dot, I wanted to release the block. So let's do that. So let's go here. We need to make the end effector release the object. So let's write a function release object. Okay, and I need to code that. So let's just code it right on top here. Function release. Okay, now turns out that the release function is much simpler than you think. It's basically using the same command, but instead of attaching, you just detach it. So what you do is, I'll copy this. Okay, and I'll copy the syntax. So here I set the attached shape to be connected to the connector to be true. All I need to do now to release the object is to say that I need to connect the attached shape to the ground. Right? and that's it. And just need to connect it to the ground. So -1 is okay. Let's see if that works. Okay, so it released it, but it went flying off, and that's because of this. I'll show you the problem. The problem is that it sort of is doing this, setting the position and then releasing at the same time. It's doing it for 3 seconds. So that basically puts an impulse, sort of uh, pushes the object to uh, when it shouldn't. Like it shouldn't be doing this simultaneously. So what I'm going to do is I'm just going to separate this out a little bit. I'm going to change this from 9 to 11 seconds. And then I'm going to, actually separate this action totally out. Let's say from 11 to 12. Okay, so just breaking the logic so that it sort of stops at 11 seconds from setting up the position and just releases the object. Okay, there it is. Looks good. Let's run it again. Okay. Now, one thing you want to remember here is that these is kind of interesting that we made attached shape as an object here, and then we used it here. These variables in Lua are global variables, so they can be used anytime. Now, sometimes you don't want that to happen, right? You don't want to use the same name for them because somewhere else you might be having another manipulator attaching a shape. So what you can do is you can actually return a value. So you can say return attached shape. Okay, so it returns attached shape. What I can do now is right here in the code, I say that shape. So it's a note that it is a different name. It's not the same name. Okay, so this call will now return the shape which was attached, and then I can pass that as an input argument to grasp object. So I call it shape attached. It will go here, and then okay, so that way I can basically not have global variables. Let's see if this works. Okay, it worked. So that's the way in which you can return variables, which is useful sometimes. Okay, so that's basically concludes how to use CoppeliaSim to do pick and place. Now the caveat here is that these motions don't look realistic, right? You don't have a manipulator doing things infinitesimally fast like this. Okay, so what I'll do next class is to actually show you how you can move this gradually from point A to point B and point B to point C. And I'm going to introduce an idea called finite state machines, okay, which is actually very important in robotics. Most of the robots program use something called a finite state machine. There was a question, can line 17 be replaced with the proc sensor to be able to pick any size box? Let me see line 17. Line 17. The issue is that so okay, so if there was a big, so this box was of dimensions 0.1, 0.1, 0.2, 0.2, 0.2. So I had to subtract 0.1. Now, if I did not know the size of the box, right? Let's say it was a 0.5 by 0.5 meter box. How will I modify this? So in that case, what you would need to do is you need to sort of have a homing action. Homing is in robotics, homing is when you are trying to get to something, you sort of go close to it fast, but maintain a certain distance, and then you go slowly to see that it's actually there. So what that would mean is if you know that the box is this big, then you will sort of go here, you'll have the end effector here, and then slowly start going down and with the proximity sensor so that you know that, and you'll keep sort of detecting the box and see when if the box is visible or not. And some point of time when you know that the box is close enough, that's when you'll attach. So yes, so if you have a generic box whose dimensions are unknown, then this code will not work, and you will have to do a little bit more complex calculations than this, which is basically the homing action. Go slowly, see the box, then pick it up. Okay, any other sort of like a probe? Yes, it will be used like a probe. Okay, so any questions? Okay, so I will release the final project soon, but what change I'll make to this, it will be a three-dimensional arm. Okay, it'll be UR5, which you did for the homework. And to add a little bit of excitement to that project, what I'll do is I'll actually have um, blocks of red color and blue color, and you will have to basically use a color sensor to detect the boxes, so the box color, right, and then place it in a separate location based on the color of the block. So it's not going to be, it's going to be a lot of clicking like I showed you, but I believe that what I'll show you will translate to that box in 3 dimensions. It won't be too much of uh, uncertainty like you had in the project 3. So that's my hope. We'll see how it goes. Okay, so I will stop here. I will see you on uh, Friday. There's a question: what happens when there are two dynamic boxes? Well, if there are two dynamic boxes, you will only hopefully detect only one box, because this code ensures that, right? If you have two boxes, then since you're using the probe proximity sensor, then you can basically detect the box which is in the vicinity. So you'll only attach to that box. In fact, next time in the class, I'll show you, I'll put 3 boxes or 4 boxes there, and actually it'll work. You pick one box, put it in the black position, and so on.